We're going to talk a little bit more about domain and range. Domain and range is a very important thing when it comes to functions of any kind, especially once you start putting them into real world situations and you're talking about actual objects. So quick reminder what domain and range are first. Domain, remember, is all of the possible x values that a function can have. So all the x values for which it is actually defined. And your range then, process of elimination, is all the possible y values for which your function is defined. And it's not necessarily just functions, it can be relations also. So with your first year of algebra, you dealt with some that weren't necessarily functions. Maybe they were just lists of points. So it might have been something like this one right here. So given this relation, what's our domain and range? Domain is all the x values for which it's defined. So we look through all of our x values. We have 1, -5, and 0. And generally with domain and range, you want to go from least to greatest. So we're going to list our domain. And since it's in a list, that's what these little brackets on the outside are, our domain and range are going to also be lists. So lowest number, -5, then 0, and then 1. So that's my domain for that one. My range, I have 2, 7, and 3. So least to greatest is going to give me 2, 3, and 7. So you saw this in your first year of algebra. You also saw things like this. These are the main graphs that you dealt with. So we have linear. Linear is really easy with domain and range. Look at all the x values that you can have for a line. Is there anything xy's that this line is not defined? No. It works for everything. So this is all real numbers. That little symbol is real numbers in case you've forgotten that or didn't know that before. There's symbols for all different kinds of sets of numbers that you'll learn throughout the year. Range, y values. Are there any y values that this line is not defined for? No. We can get any y that we want. So this is also all real numbers. And then you dealt with quadratics. Quadratic, domain's really easy again. Domain is all real numbers. There's nothing that we can't plug into x into our parent function. Remember, our parent function for this is y = x squared. So when you're looking at domain, you can think, okay, is there anything that I cannot plug into x and get a number? No, I can plug in anything. I can plug in a negative and square it. I can plug in a fraction and square it. I can plug in anything. So my domain is all real numbers. And then for this specific graph, this equation does not match this graph, by the way, you'll remember, because my vertex is not at 0, 0. So this was just parent function. This is for any quadratic. The range on a quadratic depends on our vertex. Vertex is our highest or lowest point depending on whether this is an upward facing or a downward facing quadratic. So this one's facing up. I look at my vertex, which is right here. And then I know that my y value for my vertex, this is at -3. So all of my y values are above or at -3. So my range is above or at -3. And remember, there are different ways for you to represent your domain and range. You can do inequality notation, you can do interval notation. You've probably done inequality the most up till now, so we'll write our range in inequality. So y has to be greater than or equal to -3. And that's our range for our quadratic. What we're going to spend time talking about today are ones that are a little bit more complicated. So they're discontinuous functions and piecewise functions, and they're a little trickier. So ones like this. So take a second, look at that, see if you can figure out what the domain and range is. Well, it's a little more difficult because of the different pieces. Now, you don't necessarily do domain and range by piece. You don't go, okay, what are the x values for this piece? What are the x values for this piece? What are the x values for this piece? You're looking at the graph as a whole. My favorite little tool for doing domain and range with piecewise functions or relations that are a little bit more interesting is a paperclip. So I have my little paperclip here, and I flatten out my paperclip. Not flatten, straighten out my paperclip. Paperclip's already flat. So that it's like this. And this is kind of my line. So if I want to do domain, I'm looking at X values that are defined. So what I'm going to do is I'm going to take my paperclip and go to the furthest left that I can on my X values. I'm going to start over here, and I'm going to pan across the graph. I'm looking for where does my paperclip actually touch the graph and where does it stop. So there's an arrow here. That means that this line goes forever and ever and ever towards negative infinity. So I know that it's negative infinity, and I'm going to keep going across until my paperclip doesn't hit the graph anymore. I have to stop here. Why do I have to stop here? Because there's an open circle. Remember, open circles are not included in our graph. So my paperclip isn't actually hitting the graph right here at, what is that, -6. Okay, so the first part of my domain is negative infinity to -6. I'm going to use interval notation on this. Interval notation uses brackets and parentheses. Remember, you'll use a parenthesis for infinity because you can never include infinity. It's not an actual number. You can't have infinity pennies. I don't care what you said when you were 4. You can't have infinity. So it's parenthesis. And it goes all the way to -6. Is -6 included? No, it's not, because it's an open circle. That means I have to have a parenthesis. So that's the first section of my domain. Then I keep going with my paperclip. Where does it hit the graph again? Oh, it hits the graph here at -4. Is it included at -4? Yes, it is, because it's a closed circle. So now that I have another section, I'm going to use union between my sections. And because it's included, I use a bracket. So this goes -4 to, where does it stop when I pan across with my paperclip? Stops right here at 0. It's as far as I can go. Is it included at 0? Yes. So I use a bracket because it's a closed circle. And I keep going. Does my paperclip hit the graph again? Yes, it does. So I need another section. So I'm going to put a union. And I think we'll just scoot this over and use that. Where does it pick back up? Picks back up at X value of 2. Is it included at 2? No, because it's an open circle, so I'm going to use parenthesis. So 2 all the way to. And then where does the paperclip not hit the graph anymore? Well, on this actual piece of paper, it stops here, but there's an arrow here, which means that it keeps on going. And this looks like part of a quadratic, so that means that it's going to keep on going further and further and further right, no matter how far I go. So this is actually going from 2 all the way to positive infinity. And remember, infinity is with a parenthesis because you can't actually include it. So there's my domain. That's with interval notation. You can also do it with inequality notation, but when you have this many sections of your domain, it gets a little messy looking. So I would suggest using interval, and that's what you'll see used most of the time for these kinds of functions. So then we're going to take a look at the range. Range is y values. So instead of taking my paperclip and panning left to right, I'm looking at the y values. Y values are up and down, and I need to go least to greatest, so I'm going to start down. We'll do that for now. So down at the bottom, I pan up, 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 up. Oh, there I hit a value on my graph. Where is this? This is at y equals -2. Is it included or not included? It's not included because it's an open circle. So my range is going to start at -2, and it's going to be a parenthesis because it's not actually included. Then I'm going to keep going up. It's always hitting my graph. Now it's hitting the graph twice. Now it's hitting the graph in 3 spots, but it's still hitting, still hitting, still hitting. Up, now I have this arrow. I'm still going to be hitting the graph no matter how far up I go, because this arrow tells me that the line keeps on going. So this is never going to stop. It's going to go all the way to positive infinity. So my range is actually a pretty short and easy one for this. -2 to infinity. This one you could write as an inequality without it being so messy. So this would be y is greater than -2. Don't put inequalities and infinity symbols together. Don't say y is less than infinity. That doesn't make sense, because infinity is not an actual number, it's a concept. So try not to put infinities in greater than and less than inequality notation. It just kind of looks weird. But you won't be technically wrong if you do.